Part 9 review. This is your teacher, yours truly, Journal Philia, LPD. So the coverage of this review are as follow: the variation, namely direct, inverse, and joint variation, ratio and proportion, similar polygons, and similar triangles. Number 1, y varies directly with x is translated as. So our word here is directly. If the word involved is directly, we will simply multiply the constant of proportionality to the variable. That is, y is equal to k times x. Directly multiply. Inversely, that is to divide. That means y varies inversely with x is y is equal to k over x. If y varies directly with x, what is the constant of proportionality if y is 10 when x is 5? Now we know that in direct variation, we simply multiply the constant of proportionality to the second variable. Y varies directly with x is y is equal to x times k. Now we want to know the constant of proportionality. If y is 10 when x is 5, simply substitute the value of y and x to the equation. That is, 10 is equal to k times 5. And k times 5 is 5k. To get the value of constant of proportionality, simply divide both sides by 5 to get the value of k. K therefore is equal to 2. This is the constant of proportionality. In the proportion a over b is equal to x over y, what values are referred as means? When we talk about means of a proportion, that is the inner value. So the inner values for this proportion are b and x. How about its extremes? Extremes can be found at the outer part of your proportion. That is a and y. These are the extremes. If a varies directly as b and a is 9 when b is 3, what is b when a is 6? Now we know that directly means to multiply the constant of proportionality. A varies directly as b is a is equal to kb. Now we will use a is 9 when b is 3 first to know the constant of proportionality. That is, a is 9 and b is 3. To get the value of k, simply divide both by 3 to give us 3. Now 3 is the constant of proportionality. Now we will substitute it to the formula. So the model expression is a is equal to 3b. Now we will use this formula to answer the question, what is b when a is 6? Simply multiply or substitute a with 6. That is, a is equal to 3b. To get the value of b, simply divide by 3. And 6 divided by 3 is 2. b is 2 when a is 6. A varies inversely as b and a is 9 when b is 3. What is a when b is 9? Inversely is divide. A varies inversely as b. Now we will use a is 9 when b is 3 first to get the ratio of proportionality or constant of proportionality. That is, 9 is equal to k over 3. Cross multiply, 9 times 3 is 27. That is the constant of proportionality. Now we will substitute this k to the first formula to give us a is equal to 27 over b. Now we will use this model expression to answer the question, what is a when b is 9? We will substitute b with 9 to get the value of a, and 27 divided by 9 is 3. Therefore, a is 3 when b is 9. Now let's talk about similar triangle. What is the ratio of similitude of the smaller figure to the larger figure? Now, in order to get this ratio of similitude, simply get the proportion of the two triangles. Now, since given here are sides, we will know, or we will determine first the corresponding sides of the two similar triangles. So that is 35 over 14 is equal to 14 over 16. So that means side with 35 unit corresponds to side 14. Side 40 corresponds to side 16. That is 35 over 40 is equal to 14 over 16. Now we will simplify. So in order to get the ratio of similitude, we must get the same answer when we reduce these two fractions. 35 divided by 40. So in order to simplify this one, all you have to do is to think of a number that can be divided by 35 and 40 without getting any remainder. That is 5, right? So 35 divided by 5 is 7 and 40 divided by 5 is 8. Same process goes to 14 over 16. Think of a number that can be divided by 14 and 16 without getting any remainder. That is divided by 2. 14 divided by 2 is 7 and 16 divided by 2 is 8. As you can see, we have the same fraction, we have the same reduced fraction, and this is the ratio of similitude. 7 over 8. What proportions can be used to solve the similar figures? Now again, in order to solve for similar figures, we have two conditions. First, all angles must be congruent. Second, all sides must be proportional. Corresponding angles are congruent and corresponding sides are proportional. Given here are sides, we need to know the corresponding sides that are proportional. So we have first 3 over x is equal to 24 over 32. It simply means that 3 corresponds to side of 24. X corresponds to side of 32. Or we can say also that 3/4 is equal to 24 over 44. Side of 3 corresponds to side of 24. Side of 4 corresponds to side of 44. Last one, we have 4 over x is equal to 44 over 32. Side of 4 corresponds to side of 44, and side of x corresponds to side of 32. These are the proportions need to use to solve the similar figures. Now let's look for the given figure. We need to know the perimeter of ADE is the perimeter of ABC. So our ADE has the following measure. AD is 6, DE is 3, and AE is 7.5. Now, as we can recall, that to get the perimeter of a triangle, that is simply what? Simply get the sum of all sides. So in triangle ADE, the following sides are side AD, side D, and side AE. So we need to know the sum of these three sides in order to get the perimeter of ADE. Substitute. AD is 6, D is 3, AE is 7.5. Compute for the sum. Perimeter is 16.5. That is only the perimeter of ADE. Now we look for the perimeter of ABC. So in ABC, AB is 4, BC is 2, and AC is unknown. And now in order to get AC, we will use the AE and CE. As you can see there in the figure, AC plus CE is equal to AE. In order to get the value of AC, we simply subtract AE to CE to get AC, which is 5. So in order to get the perimeter of ABC, simply add the following sides. Again, AB is 4, BC is 2, AC is 5. 5 is the value of AC. And that is AE minus CE. And then the sum is 11. Now get the ratio of the perimeter of ADE and the perimeter of ABC. So perimeter of ADE is the perimeter of ABC is 16.5 is to 11. Now we can simplify this further by simply moving the decimal point of your numerator to become it whole number. Now, the rule here is that whatever you do to your numerator, it must be done to your denominator. Since we move one decimal unit in the numerator, we will move 1 unit also to the denominator. So 16.5 is to 11 is also 165 is to 110. And simplify this fraction, it will give us 3 is to 2. Now this is the perimeter of ADE, is the perimeter of ABC. Now for the side DE is to side BC. DE is equal to 3 and BC is equal to 2. The DE is to BC is simply 3 is to 2. For AD is to AD, AB is equal to 4 and AD is equal to 6. Ratio is 4 is to 6. To simplify this one, think of a number that can be divided both by 4 and 6. That is 2, right? Without getting any remainder. 4 divided by 2 is 2, and 6 divided by 3 is, 2 is 3. Thus, the reduced ratio of AD is to AD is 2 is to 3. For his body budget, Mr. Nell partitions his earnings in the ratio 5 is to 3 is to 2. 5 for wants and needs, 3 for wants and savings for 2. If he earned a total of 19,000 this month, how will he partition his earnings? Now we will divide the 19,000 into needs, wants, and savings with the ratio 5 is to 3 is to 2. Now in order to get the value for needs, wants, and savings, we will use the formula. We have 5 is to 3 so 2 is equal to 19,000. So simply add the ratio. So we will assign the variable here for the ratio since we want to know how much is the need, how much is the want, and how much is the savings. So 5 is to 3 so 2 becomes 5x plus 3x plus 2x is equal to 19,000. Combine line terms, 5 plus 3 plus 2 is 10x is equal to 19,000. To get the value of x, simply divide by 10 both sides to get 1,800. Now this is the value of x. Then we will substitute to the following needs, wants, and savings. Needs again is 5x and 5 times 1,900 is 9,500. For the wants, we have 3x. 3 times 1,900 is 5,700. And for the savings, that is 2x. 2 times 1,900 is 3,800. So these are the following partition for his earnings. Needs, 9,500. Wants, 5,700. Savings, 3,800. When we add these three numbers, we will get 19,000. The corresponding altitude of two similar triangles are 7 and 15. If the perimeter of the smaller triangle is 21 units, what is the perimeter of the larger triangle? Now, since we're looking for similar triangles, corresponding altitude 7 and 15, perimeter of smaller to larger is 21 is to unknown. Now we will use this proportion. 7 over 21 is equal to 15 over x, where 7 is the altitude of smaller triangle and 15 is the altitude of bigger triangles. 21 is the perimeter of smaller and x is the perimeter of the larger. Cross multiply to get 7x is equal to 315. Cross multiplication. Get the value of x by simply divide both sides by 7 to get 45. Now, to answer the question, the perimeter of the larger triangle is 45 units. A flag has a length of 45 inch and a width of 30 inch. What is the length of similar flag with a perimeter of 210 inches? Now we will draw with the two polygons here. So we have a flag, rectangle. Length is 45 and width is 30 inch, and the other flag has a perimeter of 210 inches. Now in order to look for the length of a similar flags, one given are dimensions, length and width, and the other given is the perimeter. So we need to know first the perimeter of the first flag. So in order to get the perimeter of the flag, since this is in rectangle shape, perimeter is equal to 2 length times 2 width. Length is 45 and width is 30. 2 times 45 is 90 and 2 times 30 is 60 to get 150. Now this is the perimeter of the smaller flag. Now we will proceed to the proportion. Our proportion is perimeter of smaller over perimeter of larger is equal to length of smaller over length of larger. Substitute. Perimeter of smaller is 150. Perimeter of larger is 210. Length of smaller is 45 and length of larger is x. Cross multiply to get 150x is equal to 45 times 210, which is 9,450. Divide by 150 to get 63 inch. Now this is the value of the length of similar flag with a perimeter of 210 inches. That is 63 inches. Three known numbers are in the ratio 5:6:7. Is it possible that the numbers are 20, 24, and 28? Why or why not? So here we'll use the ratio of proportion or ratio of similitude. As you can see, our ratio of 5:6:7, and the possible numbers are 20, 24, and 28. So in order to get 20, what did we do to 5? We simply multiply it by 4. How did we derive the 24? Simply multiply 4 by 6. How did we derive 28? By simply multiply 4 by 7. And thus the ratio of similitude is 4. Last question. Are all isosceles right triangles similar? The answer is yes. Since isosceles triangles or triangles with two sides are equal. If we're dealing with isosceles right triangles, one of the angles is 90. Therefore, the other two angles are equal to 45 degrees. So these are all isosceles right triangles with the following measurement of angle: 90, 45, 45. Congruence angles are congruent, then sides are also congruent, are proportional rather.